To calculate gravitational potential energy, you are going to need this formula. So big E subscript P equals mass times G times the change in height. So don't forget, we measure mass in kilograms. We measure G, it's a constant, it's the gravitational field strength, and we've all come across that before in this unit. It is 10 newtons per kilo on Earth. So if you're on another planet, it's got another value, but on Earth, that's all we need to know. You don't need to plug in all the units, just 10 will do. Height is measured in meters. So don't forget that this energy is measured in joules. Yep, it's the same joules you see on your cereal packet. So a joule is a joule is a joule. It doesn't matter if it's a joule that comes from food, a joule that comes from gravitational potential, or a joule that comes from kinetic energy. So let's have a look at an example so we can see what's going on with this equation. So I've got a ball here and it's 1 kilo and it's 5 meters above the ground. So what this equation is telling us is that gravitational potential energy depends on the height above the ground, also the object's mass. So if the object has the same mass, the higher you lift it above the ground, the more gravitational energy it's going to have. So now let's use the equation to do the calculation. So this is a typical type of question. Calculate the gravitational potential energy of the ball lifted 5 meters above the ground with a mass of 1 kg. So first of all, you've got to identify the height above the ground, so we know it's 5 meters, and the mass, 1 kg. So once you've got your variables, you just have to plug it into this equation, mgh. So the mass is over here, 1 times g, which we know is 10, times h is 5 meters. So 1 times 10 is 10 times 5 is 50. So we get 50. 50 what? Don't forget your units, 50 joules.